Okay, so welcome back to my YouTube channel. So last class we were discussing the exact differential equation. So we saw that the first we need to check for the condition for exact differential. So dou m by dou y is equal to dou n by dou x is the condition to check the exactness of a differential equation. So this is the general form of this differential equation. So we saw the derivation also in the last lesson. So we came up with a formula for this. So this was the final solution of this type of exact differential equation. So we then saw a illustration. So this illustration we have already seen. Then we've solved one problem also. So let's continue with where we left. So we will solve three more problems for better practice in this video. So let's begin. So first problem, if you see, so what we will do, we will first check for the exactness of this differential equation, then we will apply the formula. So I want that you should first pause this video and try to solve this by yourself, and once you are done, then we will see the solution. Okay, so let's start to solve this question. So if you see, this is m and this is n. So what we have to find, dou m by dou y, dou m by, so you can rewrite this over here, x y square plus 4x cube. Okay, so when you partial differentiate with respect to y, so here you can see that there is, this is one term and this is second term. So you have to apply product rule of the differentiation, and you have to keep in mind that in this x is constant because we are partially differentiating with respect to y. So when you do this, so you will get, so first let's differentiate this, so you will get 2y and remaining term will be constant. Now in second time, what we will do, we will leave y square as it is and we will differentiate the e to the power term. So you will get e x y square, and also you will get a 2y x because this is not y. Then now let's differentiate the third term. So this will become 0 because we are partially differentiating with respect to y. So you get this 0. So now let's find out dou n by dou x. So here y will be constant. So dou x, so rewrite it again, 2x y e to the power x y square minus 3y square. Okay, so when you start differentiation, here also you will see two function. This is the one function, this is second function. So here also you have to apply the product rule of differentiation. So when you will first differentiate the first term, so you will get 2y and remaining term will be constant. Then the second term you will differentiate and the first term will remain constant, e to the power x y square, but y square will also come. So we know that the product rule of differentiation, like dx by, if u and v you are differentiating, so first you will leave u as it is and differentiate the other one, and the second is you will differentiate u and keep the other one constant. So it is a very common differential, so that's why I was not expanding too much on this. So now we have differentiated the first term. Now the second term, if you see, it is a function of y and y is constant when you partially differentiate with respect to x. So here you will get a 0 over here. So now let's compare. So if you see that this term and this term is exact same. Similarly the second term, this term, here you will see 2x y cube into e to the power of x y square, and here also if you see, this term is also 2y cube x e to the power x y square. So again these two terms are same and the next term is 0. So here you will see that dou m by dou y is equal to dou n by dou x. So this equation is a exact differential equation. So now you can apply this formula that we have seen. So this formula you can apply here. So what we will do is, let's apply this formula. Here y will be constant and m dx, so m is y square e x to the power y x y square plus 4x cube dx. And now the n term, so n term without x, so you will exclude this x term and just this, so minus 3y square dy plus c equal to 0. So now integrate this. So integrating this, you will see that here y is constant, so y will be as it is, and integrating this, which is a function of x, so e x y square, and since this is the constant, it will come in denominator. Then the next term is 4 x to the power 4, because again we are integrating x cube, so we will get x to the power 4 by 4, plus again we will get minus 3 y cube by 3 when we will integrate the y square term, but finally plus c equal to 0. So you will see that this gets cancelled with this gets cancelled with this, similarly 3 will get cancelled with this 3. So rewriting it, e to the power of x y square plus x to the power of 4 minus y cube plus c equal to 0. So this is our final solution of the differential equation. So let's move to the next problem. Okay, so you can first pause this video and try this problem by yourself, and after that we will solve it. So let's start. So this is the mth term and this is the nth term, m and n. So what we will do, we will first check for the exactness. So dou m by dou y we find always. So dou m will be, so let's multiply this x inside this bracket, so 2x cube plus 3y square x minus 7x. So when you differentiate with respect to y, so this is a partial differentiation, so x is constant, so here you will get the first term as 0, the second term x is constant, so 3x will come outside, and if you differentiate y square you will get 2y. Then again the third term x is only there, so it will become 0. So we got 6xy. Now let's find out dou n by dou x, where y is constant. So partially differentiating with respect to x, you will see that the nth term is here, also multiply y inside the bracket, so 3x square y plus 2y cube minus 8y. So this second term and third term is again only a function of y, so they both will become 0, and first term we get 3y is constant, and when you differentiate x square you will get 2x, so again here you will get 6xy. So we can see that both are giving 6xy, so here dou n by dou x is equal to dou m by dou y, so it is our exact differential equation. So now let's find the solution by using our formula. So what we will do is we will integrate m dx assuming y is constant. So m is 2x cube 3y square x minus 7x, and next term is n terms without x. So here you will see that this and this is the term without x, these two, and this term has x, so we will not consider this. So 2y cube minus 8y, integrate with respect to y, plus c equal to 0. So now let's solve this. So you will get 2x4 by 4 plus again 3y square will be constant, x square by 2 minus 7x square by 2 plus 2y4 by 4 minus 8y square by 2 plus c equal to 0. So here this is our final solution. So we will see one more problem. So let's solve this third problem. So you can pause this video and you can try this by yourself. So first we have to rearrange this. So when you rearrange this, you will get dy by dx. So taking this term on the right hand side, so it will be minus of y cos x plus sin y plus y divided by sin x plus x cos y plus x. So now you will multiply this on, means cross multiplication, so and bringing on one side, so you will get this as y cos x plus sin y plus y dx plus sin x plus x cos y plus x into dy equal to 0. So this is our normal m dx plus n dy form. So what we do, we first find out the dou m by dou y, and we try to check whether it is equal to dou n by dou x or not. So finding the dou m by dou y first, so m is dou y, so m is this term, y cos x plus sin y plus y. So here cos x will be constant because we are partially differentiating with respect to y, so cos x will be as it is, and then when y is differentiated with respect to y, you get 1, plus when sin y is differentiated, we will get cos y, then again you will get 1. Then let's differentiate dou n by dou x. So here y will be constant, so dou n by dou x, so n is this term, sin x plus x cos y plus x. So this you will get cos x here for the first term differentiation. The second term, this is constant cos y term, and you will get 1 for this differentiating x with respect to x, plus again you will get 1. So if you see this again here, this term and this term is same, so this is our exact differential equation. So we have checked it. So now we will solve it by using the formula. So when you apply the formula, we keep y as constant and we integrate m with respect to dx. So m is this term, so y cos x plus sin y plus y, we integrate with respect to x, and n terms without x, so this and this we will eliminate. This is also like, so there is no n term without x, so here you will get 0 dy plus c equal to 0. So integrating this first term, here y is constant, so y will be as it is, and then cos x integration is sin x. Then again these two terms are constant because y is constant, so sin y plus y, and x will come outside because we will integrate with respect to dx, then plus c equal to 0. So this is our final answer. So I hope that you have understand, and also you have practiced these questions. So we will come up with the next topic in the next video, so where we will study about how to solve for the differential equations which can be brought to the exact form. So see you then. Thank you.